So here's quadratic inequalities in one variable. Now, you're probably saying to yourself, wait a second, one variable? What are you talking about? Quadratics? Wait a second, I know what quadratic is. A quadratic has to have an x squared. And inequality, yeah, you gotta be this, 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 and this, okay? Those guys right there. Greater than, less than or equal to, blah, 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 blah. Okay, but how is it one variable? Because it's gonna be one variable because every y is gonna be equal to 0. Ah, I see. I know what you're going after here. So that means you only have, guess what? If your y is 0, you only have the x's to deal with. That makes things a whole heck of a lot easier now, doesn't it? Well, same thing as I've always told you though. Ignore everything. Just do what comes naturally. And what comes naturally, of course, is PSA. Always go back, factor this like nothing has happened to it, put down your critical points, then go from there. So -3, -2, you know that's -3 times 1, that's -3 plus 1, so your answers are -3 and 1. So this is x minus 3, x plus 1. Ignore this. Make it just equal to 0 for now. We'll get back to that in a minute. You know that x then will equal to 3 and x equals to, in this case, -1. So plot the two critical points. There's the -1, there's the 3. You also note that this has a y-intercept at -3, so it's got to be down there. Last thing that you can do is plot the vertex. Okay, so starting here, 1, 2, 3, 4. So you know it's 2 ticks away. 1, 2. So your vertex is going to be at x equals to 1. It's going to be there somewhere. So again, plot that in there. Plunk it in. See what you get. Put it into here. Put in a 1 squared. Put in a 1 here. So 1 squared is 1. -2, -3. Guess what? -2 and -3 is -5 plus 1. You're going to get -4. So your vertex is x equals to 1. Y equals to -4. How beautiful is that? So 1 minus 4, there's your vertex. Start drawing this. Look at it. Axis or symmetry. Ba-da-ba. Tells you that that's 2 points are symmetrical to each other. So you're going to get something that looks like this. Now, here comes the crunch. It asks you in this question. Let's go back now. And now that we've got all of this mess done and it beautifully plotted and everything else, let's go answer the questions. This asks you here, remember, that is your boundary. That's your fence. We want all values of your fence that are less than 0. Well, what's less than 0? It has to be below this x-axis. That's down here. That's less than 0. But think about this. This is your fence. Where are your values less than 0? Well, from here to here. This is the section here that is less than 0. And guess what? That's your answer. That's it. No shading, no nothing. That's your answer. Wow. Wait a second. What are you talking about? Look, here's your critical point at -1. Here's your other critical point at 3. All values that are less than 0 are in this loop right there between -1 and 3. Greater than or equal to -1, less than or equal to 3. There's your answer. That's as easy as it comes. And I think this is even easier than linears. What do you think?